Good day, everybody. My name is Jason Straith with the Cloud Pass Virtual Group. Today we have Russel Loski. He'll be presenting querying semi-structured data in Azure Data Lake with U-SQL. Before we begin, I do have a couple announcements that I want to go through. The first being is that this presentation is brought to you by Spotlight Cloud. They are the sponsor for our user group and helping, or our virtual group, helping us to deliver these sessions on a fairly regular basis. And so Spotlight Cloud is the first Azure-hosted database performance monitoring solution focused on SQL Server customers, leveraging the scalability, performance, and built-in security of Microsoft Azure Cosmos DB. Spotlight combines the best of the cloud with Quest's engineering insights from years of building database performance management tools. If you haven't had a chance to check out what they have, I do recommend doing so. If you are interested in presenting, please let us know and we will try to actually get you into the schedule. There's a couple ways that you can submit yourself for presenting to our virtual group. The first being just reaching out to us at cloud@pass.org. I'll respond back and we'll start getting things rolling. Or if you want to just get out of the email and just send me some information so we can finalize things, you can just submit through our form at Cloud Virtual Group website at cloud.pass.org, and on that site there is a link that you can go to get to the call for speakers. So either way, we can get you onto the schedule and we can start getting you out there to talk to us about what you're doing in the cloud with data platform. Now with that, I'm going to wrap up the announcements, wrap up my part of this session today, and hand things over to Russell. So today's session, as I mentioned, is querying semi-structured data in Azure Data Lake with U-SQL. And let me make Russell the presenter.
Okay. Thank you, Jason.
Oh, you're welcome. There you are. You are now
I am now the presenter. Okay. So what I'm going, just a little bit about me before I introduce the topic. I'm an ETL developer in the Dallas-Fort Worth area, and I'm heavily involved with the SQL Server group, the North Texas SQL Server Users Group here in Texas, actually working on the board with that group. And I think my biggest role right now is I'm a granddad for a very active 8-year-old, and what brought me to this topic is I'm very curious about data. Any kind of data, whether it's structured, semi-structured, and trying to get insights out of that data has always been something I've enjoyed doing. Currently, I'm a BI developer at RDX. We're a remote database administration company. If you're interested, talk to me. Send a text or send me an email. This is my contact information. If you need it, I'll be putting my slides, I'll provide them with Jason so you can put them on the website. So what we're going to talk about is what a data lake is. And we'll talk about how you can use U-SQL as a language which looks just like Transact SQL and C# to pull data out of your semi-structured files. We'll look at data definition language. How do you define the schema on the data? Very simple. And then we'll look at the difficulty in taking a query that runs fine on one file and splitting it off. And I say difficulty in sarcasm. It's not that difficult. And then briefly I'll introduce the idea of using catalog items like U-SQL views to be able to encapsulate the logic that you find in your files. And then finally, we'll look at how you can join files just like you join tables. This came out of a problem that I had at the last place I worked. One of the people was trying to find out how many people belong to a particular program. And as he was querying our data warehouse, it was like he could never quite get the numbers right. And he speculated, if I could get to the files, maybe I could get better answers. So, as he's looking at it, he's thinking, well, how do I get to these files and query them, but they're hidden away on shares, not very, kind of very loosely organized. I'm not even sure he had access to them. So the idea of a data lake is you're going to put these files into a structure so that they're accessible. Now the problem is they have to be accessible. You've got to be able to get to them. At the same time, you don't want them accessible to everybody. You know, we had patient data that we didn't want, so it needs to be secure. It needs to be easy to process. Now, for me, easy to process means I can run some kind of a SQL against it. For him, it was being able to run R scripts against those. But even if I can process it with SQL or R or Python or something like that, it still is going to involve pulling data from the file share onto the local machine, and the cost that's associated with that, you can imagine, with terabyte of data or terabytes of data, trying to bring that across. So if at all possible, it'd be nice to process the data close to where it's at. Okay, and that's where the data lake comes. A data lake, we're going to be gathering data into a structure. So, normally it's going to be unstructured data into file folders, normally distributed. In the case of Microsoft, they've added what's called Azure Data Lake Store, and they have 2 generations of it. Gen 1, which has been around, I'm not sure how long, it's been around at least 3 or 4 years. It's a place that you can store data, and as you store it, you will pay only for the data you store. So if I've got about 200 gigs of data, I'm paying approximately $20 a month. It may be a little bit less to store it in that structure. They've added, I think it's been available, general availability for maybe 6 months. They have a Gen 2. I won't be talking about that. One of the complaints about this U-SQL is that you can't host your Azure Data Lake analytics on a Gen 2. So I won't be talking a lot about that. Now, the tools that you can use in a data lake, there's various analytic tools: Hive, Pig, MapReduce, there's Spark, Scala, Databricks are all tools that you can use to analyze the data. All of them will work on the distributed file system, will work in Azure Data Lake. Microsoft has added the Data Lake Analytics and provided U-SQL as their tool, one of their tools for analyzing the data. Okay, so to demonstrate this, I'm going to be using a set of data which I call its public use microdata sample. It comes from the American Community Survey. They're doing mini census all across the country every year. They're getting a sample of households and sending out questionnaires that look something like this. These are the questions related to healthcare, and then they get the responses back. And they publish them as summaries that you can read, but they also provide what are called public use microdata samples. And these, they almost represent each questionnaire that was filled out. Now they've done some, made some changes to the files. For example, there are some answers that they are going to obscure. For example, high incomes, there's so few people that would have, say, $20 billion income. They will obscure that so that you can't go, oh, I know what this person makes. Or if a particular area has too few samples, they will just not even put those results out. Okay, so I've had these files for a long time, and I'll talk I think I've been gathering them since 2005. They look like a fascinating set to work with SQL. And when I tried to pull them into SQL, the thing that hit me is they have about 150 to 200 different columns, and trying to do all the analysis of that to make it work in SQL, to make it, it just kind of overwhelmed me. Finally, I gave up until I came to U-SQL and realized I didn't have to know what was in those files. Okay. Some of the features of this PUMS data, they have two sets of files. They have what are called housing data and people data. Housing data is going to have things about the household as a whole. People is going to be individuals within a household. There's a one-to-many relationship of housing to people. They have data from 2000 to 2017. I will be looking at 2016 mainly because 2017 recently came out. They've changed the format, which they do every couple of years, and they've also changed the file name, so structure, so I have to incorporate that. They have all states plus DC from the beginning, from 2000. At some point, and I can't remember when, they started adding Puerto Rico to each of those files. They gather the samples for a whole year. So as they're gathering, doing their surveys for a whole year, they put those into one file. They also take 5 years worth of files and put them into another set of files. And then finally they have 3-year files. I think they did those for a short period. They're not doing them anymore. They have some of the columns that I'm going to look at have a header like ST, which represents a state, and the code is an integer. It's not an abbreviation. Then they have PGTP, which is a person's weight, and that's not how much does a person weigh, but rather it's a statistical weight. It's their estimate of the sample that the sample size that a particular record represents. Okay, so that's the person's weight. We'll look at that. They have age P, which is the age of the person, which is an integer. They have sex or gender, and we'll look at the issues in translating that. And then the health insurance coverage recode, take that questionnaire that I showed you earlier. They look at it and say, okay, is it converts all of that. Do you have health insurance through your job, Indian health insurance? Did you buy your own health insurance? And basically translates that into a yes or no. Do you have health insurance? Okay, there's 270 additional columns, and my thought is, what do you do with that? And what held me up for years was, what am I going to do? What are the data types? Do you have a design session? JAD, QA. I remember bringing a file source up to my boss, and she just looked at me and said, we don't have the 2 or 3 months to figure out what's in here so that we can bring it in. And at the end of that, is it going to be worth it? Okay. Well, what you can do is, with U-SQL and other of the big data technologies, is you design it when you need it. Okay. Well, let's just take a quick look at the file before we go forward. This is the file that is produced. You can see it has at the top, it has its header. It's all comma delimited. And then you have data down below that's of a particular form. Okay. And what I did then is I created my before I talk about that, I need to talk about setup. I always forget this. I've got some instructions. They'll be in the slide deck. Take a look at how to set up Visual Studio, how to set up Azure Data Lake, and you can see get started. Okay, so now we go to our population query. I have a folder on my Azure Data Lake store, and my Azure Data Lake store looks something like this. This is how much I've paid. I've paid about $7 for about 176 gigabytes of data on this for, I think it's the first 9 days of May. And I can click, I've created, this is my data store. And maybe it's not, my mouse is not going to take, okay. Anyway, if I go down, drill down in my Data Explorer, I know what's the problem. Let's exit the page. it's just not responding. It's the problem with loading things up front. So this is how much I've paid, and I'm using an MSDN credit. Let's go down to my Data Explorer, and you can see the data in it. As we drill down through the structures, you'll see I have these folders. Census is the one we'll be looking at. We'll be looking at some others down below. But basically, when we get down to our populate 2016, you've got a bunch of files that look about like this. They all have the same structure. They start with the characters SS, then they have the year in a short format, 2-character, then they have P, which represents person or population, and then they have the abbreviation for the state name, and then .csv. Okay, and then what I did is I've created a set of queries. Now, so I installed the extension onto Visual Studio, and then I was able to create a project of type U-SQL. I can, by the way, run these all in the portal, and I'll show you that in just a moment. I went to the Server Explorer, and if you look up in this corner here, you can see I can connect. I'm connected to my 2 subscriptions using my email, and if I were to right-click, I could then connect to my Microsoft Azure subscription. So you need to have a subscription. Okay, and we'll get rid of this. Okay, let me hide this real quick. Okay, and this is what a script looks like, and some of it, it's the beauties of U-SQL is that a lot of it, I look at it as the good, the bad, and the ugly. The good is that a lot of it looks just like SQL, or you can figure it out. The bad is that some things look like SQL, but they're treated just slightly different. Probably the ugly is if you're just a SQL person and not a C# developer, it's going to have C# in it. For me, I like C#, so it's fine. So the first thing we look at is that we've got some keywords that make some sense. You look at this declare and at. Okay, that's it's just like a variable. The one difference, and I'll mention this, just put this in the back of your head. It's not important for here, but unlike a variable, once I've set this, it's set. It's more like a constant that I'm going to use. Okay, so I can't create loops and populate variables. So it's a little bit deceptive. It's this is a constant that you can use. So if I want to use source file name later in my script, I've got it set there. So we've got declare. Okay, this string. Okay, it's not varchar, it's string. Okay, this is C#. Okay, the string identifier is double quotes. Okay, that comes out of C#. Okay, then we have down here we have something that looks like another variable, source equals, and you know in my thinking, I would think of this as being a standard variable. Maybe, you know, because I look and I see it says extract, maybe this is like a table variable in SQL. This is actually more like a common table expression. So if you've used common table expressions, just treat this just like a CT, a common table expression. Throughout this script, anytime I have at source, it's going to basically run this entire query that I've defined below here. Now, what's our query? It uses a keyword that's not like a standard SQL. It's extract. And extract is telling the U-SQL that it's going to be taking data out of a file. Okay, that file could be it could be JSON, it could be CSV, it could be a TSV, it could be Parquet. I think that's how it's said. Okay. Now, before we go, and then below here are all of my columns. And each one has the column name and followed by the data type. And in fact, this is where I'm defining what the data type of these columns are. This is schema on read. I'm determining when I run this query what the data types are going to be, what the name of the column is going to be. That's all determined at this point. When I put the file up there, it's just text, or now if I'm using something like Parquet, that's going to be defined within that, or JSON, there are some things that might be defined within JSON. But in this case, with a CSV, I'm saying this is what the column name is, this is what the column type is. Okay, while we're here, you'll notice that there are, well, you may not have noticed, but because you may have thought this is just my stylistic constraint, there are words that are all caps in this. Declare, extract are all caps. Okay. Within U-SQL is going to treat those as SQL. It's going to process them differently. Things that have mixed case or have all lowercase, those are either going to be column identifiers, they're going to be column identifiers, they're going to be C# or something along those lines. So string is C#, RT is a column name, string, etc. And just remember that. And one of the things that I find blows up all the time when I'm running scripts is I will put something into mixed case, my SQL, and it blows up, and then I go, oh yeah, that's right. I need to make those all uppercase. Okay. Now one thing, and it's annoying, but it's expected, is you go through this. I have about 270 lines, all the same. Okay. So you can see all of those lines, and you have to specify every column in your extract that you need when you're doing a CSV file. And let me just put this up just so that you can see kind of the beginning and the end. So we've got at the top, we've got our extract, a whole bunch of lines, all the way down until we have a different, we have our from statement. Okay. By the way, I didn't type all of that out. All I did was took the header on my file, put it into Excel, converted those to columns, did a transpose, and just to save time, I won't go through this. I transposed it and then just used a formula to convert all of the column names to proper case. I could have done it lowercase, as long as it's not uppercase. There's one other way I could handle this, is to put square brackets around like this. Oops. And this would also be acceptable. And if you have any C# that requires it to be entirely uppercase, then you would use the square brackets. Okay. So now when I do an extract, I have to say two things, where it's coming from, what file name, and then I have to say what tool do I use to extract the data. Okay, so in this I have an extract, and I'm saying from, and this is a string that is, this string, and I put this in a variable because I don't want it to get lost in the 270 lines of code. I want it to be obvious that it came from this particular file. Okay, then I say using, and I say what I'm using to extract the file. Okay, now extractors is a built-in class that comes with U-SQL, and really it has it's going to produce one type of an extractor, and that is a text extractor. A text extractor is a delimited extractor. Okay, so then I hit, CSV is going to be a comma delimited. TSV is a tab delimited. If I want, I can change what delimiter I want to use, and in some cases I have to. Okay, so what this is going to do is to process the file. Okay, now then let's get rid of this. So down below, I have my source all the way down here. Then I have a second statement. This isn't required, but if I'm going to shape this further, I need to have some kind of a statement, SQL, and this is another common table expression that I'm going to call SQL. And you can see right in the middle, in the from clause, rather than having that extract, I have at source. And that at source really is a derived table that would encapsulate everything up to the top here. Everything up here is going to be expanded out just like a common table expression. And then you see I've got my column names. I have a count statement. Okay, notice all caps. Again, that's a standard U-SQL syntax. I have my as, which is going to be uppercase. Okay, then I have a group by on, this is C#, right? You can't have C# without having a semicolon, right? So this has semicolons, and this does a select statement. And then I output, again, I output to a particular file, and this is going to put this up onto the Azure file system. Okay, then I have, say, I have an extractor. This outputters is just like an extractors, but it's going to output to CSV, TSV, or to another delimited file. Now, I ran this earlier because sometimes this takes a while to run. And when I run this, it's going to produce a job view. Okay, and you can see what happened when I ran this. Okay, so I submitted this job. It's called a job. I submitted it, and it then sent up. It sent that script up, and it spent about 35 seconds preparing the script. Now, when it ran that 35 seconds, I wasn't paying anything for it. Okay, so it spent about 35 seconds preparing it. It queued it, so it's ready. It's now going to be put into some queue until there's available resources, and then it's going to then run the script. It took 23 seconds to run this script. Okay, and you can see some other information about it. One thing that is very important to remember is what's called the allocation units. Okay, I said use one allocation unit. The way I picture this is the number of CPUs and the number of virtual machines that are going to run against this. I chose one, which means it's just going to run, use one virtual machine to process this. Now, if I had very large files, I might want to change this, or if I have a large number of files, I would change this. Okay, then it produces a job, basically a job graph. of this, okay? And you can see at the top the name of the file. Well, let's do it a different way. This is a little easier to read this way. It says I brought in one file, and then it took, extracted the data from that partition, and you note that it's about 17 megabytes of data were brought across. When it finished this stage, it had reduced it to 24 bytes, okay? Then it did some aggregates, and you notice this term, 2 vertices, okay? That's the number of units of work that were done. So I allocated one vertex or one allocation unit. What happens is that it runs one vertex and then it runs the second one. Now, if I wanted to, I could have bumped this up to 2 vertexes or vertices, and it might have run a little faster. In fact, I think it probably would have run about as, it didn't take much time, and I'll show you when we get bigger files how this ran. Okay, then it does another aggregate, and I'm not sure what this I think this is where it finally writes the data to my file, and notice it kind of reduced it a bit from 24 bytes to 20 bytes. And then it produced a file. And let's see if I can find this. This is population count. And this is the file that it wrote. Basically 2 rows. I think this is comma delimited. Yeah, it's comma delimited. And it has 35, which is the code that's used for New Mexico, and then the count of rows. Now these are all of the column, all of the rows in there. And then one thing that I just wanted to point out is you see this ST. It's included it's included in its query. It's included that header. Okay, that's a problem. Okay. Let me just pause for a second for you to look at it, maybe about 10 seconds, and think of what other things would be wrong with this. Okay, so we can't talk back, but some of the other things about this is that there's really no header in this file. Okay, so it doesn't have a header in the output. It treats the header as data in the file. So I want to fix that. There's one other issue with this, and that is this is counting the number of questionnaires that were sent out. A more interesting number would be to take that sample weight and to get a sum of that. But the problem with sample weight, if you looked at the structure of my query, everything is string, and you can't sum a string. I have to make some conversions. Okay, so we're going to fix that in the next query. And this is my, I've fixed this up a little. For one thing, I've changed some of the names on some of the columns. So rather than serial no or just that proper case version of it, I've translated it into serial number. I've translated it into an integer. Now this will only work if the data will parse into an integer. So just be aware that that's a problem. I've also translated this to integer. I decided on state code to leave it as string, even though it's an integer, just because it doesn't mean anything. It's an identifier. Now, but population sample weight, I translated that into an integer. Okay, and I've made a couple other changes. Let's see, age. I think there was an age P. Did I leave? I think I changed age P to age and translated that into int. And then sex, I left it as string. We'll translate that. It's, I think 1 is male, 2 is female. And then I left health insurance coverage, which is 1 or 2. 1 is yes, 2 is false, is no. Okay. Then in order to get rid of that first line, I added a parameter to my extractor. Okay. So skip first rows, first n rows. Very important. You have to have, the case has to be exactly right. So skip, and then F is uppercase, N is uppercase, R is uppercase. Okay, then I have a colon. That's going to say this is going to be the value, and then I put the number of rows that I can exclude. And this then gets rid of the that first row. By the way, there's a resource that I use, and I think it's an excellent one for starting. It was created as a stairway to U-SQL. It was created when at the time when it would not skip the first row. And so what you had to do is you had to actually physically edit the file to get rid of your headers. So problematic. Okay, now one thing I've done with this query, just to make it a little more interesting, is I added a level between my extract and my SQL, my final SQL that I'm going to output, to shape some of the data. So serial number, person number, state code, I left all as it was. Population sample weight, I included an age. And then I added a couple functions that to translate these into more meaningful things. So if you're doing any kind of analysis, especially with things like age, many times just doing age is not really meaningful. So what I have to do is put put things into buckets. And so what I've done is use a case when. Notice all uppercase, and so it looks just like your standard case statement. Okay, in Transact SQL has the end at the end, and this is going to translate into a string. So less than 18 child, less than 65 adult, and then mature adults, rather than elderly, which would be less than 65. Just like Transact SQL, I can have a when, have case and then have a column name and have it translate. So case and then my column name. Something that isn't available in Transact SQL, I can have an equal sign here. Okay, and what this is going to do is it's going to return true or false. Okay, try doing that in Transact SQL. But note the double equal sign. Okay, just like C# equals is an assignment operator. Double equal sign is a comparison. Okay, so just recognize that. And then down below, I can then use source shape, which uses my source, which is the extract, and write a query against that. And I have count, and I have my sum, just like any other statement. Every column has to be referenced. And then I do an output. And then just like with my extractor, I can have my output, I can add a parameter, and this will then output the header. And by the way, when I want to submit this, I would then hit the submit button. Make sure you set this. By default, it will be set to 5, which is more than you actually need. Okay, and when I ran this, it produced. I'll show you what the result was. I'll just show you the file that was produced. Okay, and you can see at the top we have our column headers. Okay, And then we have, you can see the translated values, and I've cut a column off. You can see the number of rows. You can see the sum of the population sample. Okay. So all of the things that I wanted to do, oh, and notice it translated this into false and true. You may need, if you wanted this to be 1 or 0, you would need to translate this in your final file. Okay. Now here's the thing. I'm running this against one file. So now what I want to do is I want to translate this into running against multiple files. And there are two things that I need to do. Probably the most difficult thing to remember is to remember to do them, okay, to do both of them. So what I can do with this in my file name, in my extract, is I replace parts of the file name with a kind of a virtual file, a virtual column. So this year, for example, year short, these are virtual columns. And what this will do is, if you look in the path, in that in the folder name, it will have a year. This will be put into this column name. Okay. The text that's between SS and P is going to be put into the year short column name, and then between P and the period is going to be put the state abbreviation. And we run this. The second piece, and this is the piece I always forget, down below, for each of those virtual columns, I have the column value. Now I put a year, I'm putting it in as an integer. If it's not an integer, you will get an error. Year short is another integer, and then state abbreviation. So both of those, and by the way, as far as I can remember, it doesn't matter where in the columns this occurs. It just has to occur. So I could put these at the top if it made sense. Okay, and then I can, I'll show you one thing I can do with this. Okay, down below, I can filter this. And what this will do is when I filter, it will actually act like a file filter, and will filter this out, okay? And it will only look at files that are in that particular folder, okay? And when I ran this, it produced, well, I won't look at the file that it ran. Look at how it processed. Okay, it took 34 seconds. And by the way, one of the things that I found over the last couple of days is that there's some inconsistency in how long this ran. I ran this with 4 allocation units, mainly because I've run this so many times that I realized that that's the best I can get. I will show you a couple things about this in just a moment. You notice it has 52 streams, but it's partitioned it into 4 different partitions or vertices. It read this, it was about 3.05 gigabytes of data that it read, and then it rolled it down to about 21 kilobytes, okay, or of data. Okay, and it ran in about 35. So it used those 4 allocation units. Now, you'll see a couple things in here. It has a view diagnostics. It's giving me a warning, and I click on this, and there'll be 2 things that it will tell me that you'll look at. Vertex execution. If I had put something other than, if I put 4 or if I put 5 or 6, it would have given me a warning. U-SQL language usage, it gives me a warning that basically it's saying that if I had a a where clause that used years short and state abbreviation, it might have reduced the number of files that it processed. Okay. Now, in this particular case, I wanted all of my files, so I just wanted everything that was in year. Okay. So that warning is not, it's good to be aware of it, but to not be freaked out. But I can look and see, could I do better on this query? And if I click on the AU Analytics tab, it produces a summary of what happened during this job. And if you look at it, this let's expand this out. You look at the job, what it starts off doing, the first part of this job, it's using all of my allocation units, but you see that line dropping down? The dotted line is what I paid for. So basically, you take that rectangle, that's what I'm paying for. As you look at it, it's starting to drop down here. It's finishing up, it's using less. And then for this last bit, it's using at the most 2. I'm not sure what this trail is, why it's not doing anything and why I'm paying for it. Okay. But I can look down here, it's suggesting some alternatives. It's suggesting, for example, that if I were to use 4, which is what I use, I would have, it's making an estimate that this would be 87% efficient. Or I could run it as fast as I could and finish it in 23. Or if I want, I could look at select custom and say, hey, let's see what would happen if I put 1 in. Notice that it jumped up to 100% efficiency. Obviously, it can't do any better than to use 1, okay? And it takes 24 seconds. Okay, now how is that information useful? I could have decided to run this with 1 allocation unit. I would be, my square, my rectangle would be smaller. I'm in terms of the area. The cost of the query would be optimal if I just used 1 allocation unit, but it would take about maybe 6 times as long to run. Okay. So I pay 6 times the cost and get, how much, let's see. No, I pay 2/3 of the cost and it runs in 20 seconds. Do I want to pay that much, or do I just want to run it for a minute and minute and 30, well, let's see, 20 seconds or so? Or do I want to get it done as fast? If my ETL window is fast, hey, I'll just do it in 20 seconds. Or I'll do it, if I have a long window that I can use, I'll just do it with 1 unit. If suddenly one night I need to run it a little faster, I know that the best I can get is 4 units, I'll run it with 4. Okay, so, and that's a decision I make when I schedule this job. It's not a decision I make when I created the job. Okay. So I won't look at the file, but it basically looks the same. It has all as the previous files. Okay. Now, what I can do is I can filter it down to 1 state. And all I did with this query, I have my state, and down below, down here in my source shape, I added the filter. And it filters it by state abbreviation. And notice again that those double equal signs. Okay, then I look at the job, and it used to be that this would run much faster. I think I'm still not sure why it's running, takes as long to run it with one file as to run with all the files. I think if I had very large files, or if I had a very large number of files, you would see this reduced. Okay. Now, I'm almost running out of time, so I'm going to look at just introduce briefly one thing. I can create a view on this, and there's no alter view in U-SQL, so I have to drop the view if it exists. So I'm going to drop the view and create a view, and then I just I can't really I haven't found a way to do an extract directly, but oh no, I know why. I have to filter it down to my 2016 at the bottom. So I basically use a derived table. So put in my from clause, I have my extract. I can't use a common table expression. I can't use that variable syntax unless I'm using a function. And then at the bottom, I have my filter. And then I had a second query. The first one, I call it raw because this is just plain giving me giving me everything in strings. And I like having that just so that if something blows up, I can put that together. Okay, then I have my my query that has all of my intelligence that I want to build into it. And I might create my own schema, or I might put my own name into it. And this has all of the intelligence I had for that. I have a script that I can run with that, but rather than see, yeah, let's see. Yeah, this is the one I wanted to show. I have have a file that has the state code in it, and let me run this. I'm going to submit this. I ran out of time in running this. This will take about 2 minutes, and I'll talk through this. I have a file that I extracted from the documentation. Has the code, it's tab delimited. I don't have a column header. I may add it in future. It has the code that's used, the name of the state, it has the abbreviation uppercase and then abbreviation lowercase. And then I just have an extract statement, and notice I have TSV rather than CSV because that's a TSV file. And then, okay, sorry, that's going to pop up over it, but we'll get to that when we need it. Then in my SQL, notice that I'm using the view. All of that extract syntax, all of my the logic, my age group and such is in my create view statement right here. So now I can reference it just like a regular SQL statement. And then the inner join, by the way, I can use that with using the common table expressions if I want, but I have different kinds of joins. I can have an inner join, left outer join, all of the outer joins. I can have a cross join. And then just to make things more interesting, they have semi joins, and they also have I think it's anti-semi joins that you can use. Okay. And then this gives me I can get the state name and add that to my job. Okay. And you can see it ran, okay, this one time it ran faster. And we'll download and you can see what it looks like. Okay, we're running out of time, so you can see how that looks. I have my as always, this is going to run. So let me jump to the end. I have some notes on different things in here, my data types. I have some resources. Okay, let's see. This is, okay, so just in closing, we looked at how to, an overview of Data Lake. We looked at how to query one file, then multiple files, and then we looked at joining files. Here's some references you can look at. The GitHub is there. There's also a blog that you can look at, Channel 9. There's their census program, and my contact information if you want to look at it. And I'm sorry, are there any questions? I know we went through this a little longer than I'd hoped.
Yeah, that's great. And this has been quite informative for me, hopefully for everyone else that's on the line. We do have a couple questions that are outstanding. What extension do you need to install for VS to support the creation of a U-SQL project?
Okay, so what extensions do you need to create a U-SQL? Let me find that. I think it's the Azure, no, it's not this one. It should be in here. I think the plugin for Azure Data Lake and Stream Analytics.
Great. And then is it possible to extract only limited columns from a CSV, or do you have to extract the whole thing when you're first accessing it?
Okay, you have to extract all of them. So you have to define all of them. What you can do then is to filter out in a subsequent statements.
Excellent. All right. Russell, thanks for presenting today. That's all the questions that we have in the queue. Everyone, thanks for joining us for this session, and this will be uploaded to our YouTube channel probably in the next week or so. Russell, you mentioned that you were going to send me over the slides?
Yes.
All right.
I'll get that right away.
Cool. And thank you again, and thank you everyone for joining. And with that, I'm going to close out the meeting.
Thank you very much. Have a good day.